Assalamualaikum. My group and I will present our FYP project entitled Review of Stabilization and Solidification Method of Contaminated Soil. My name is Norwaida Amali and my metric number AA181811. So I will present about introduction, research background, problem statement, component of stabilization and stabilization method. Introduction. So basically solidification/stabilizations very well known as established hazardous waste disposal technique. So this technique or method involved in combining weight with binder such as eggshells or oyster shells to minimize the amount of contaminants eligibility using physical and chemical characteristics to move waste to landfill or other alternative channel in the environment. So soil stabilization is actually one of the most common methods resort for enhancing the engineering properties of the soil by altering the original properties of the soil. So solidification attempts to convert the waste to low hazardous solids that are easily can be handled in the future. So the effectiveness of SS process is studied by the researchers all over the world by physical, chemical, and also microstructural methods. Research background. So during the last few decades, actually there are a lot of studies done by the researchers all over the world on the mobility and distributions of heavy metal in soil, especially for Pb and Cd, which is lead and cadmium, which are naturally occurring in the soil and can cause chronic and acute disease. And also to overcome the high cost and limited remediation technologies resources, new technologies that can be implemented at a lower cost need to be investigated. And recently, many studies have been conducted to investigate the stabilizations of heavy metal using conventional stabilizing agents such as Portland cement, lime, quicklime, and fly ash. However, there are few studies have been involved in mobilizing heavy metal using natural waste such as oyster, seashell, and a little bit of eggshell. But nowadays also, soil such as soft clay and organic soil can be improved to the civil engineering requirement by several methods of soil improvement. Basically, soil stabilizations aim in improving the soil strength and increasing the resistance to softening by water through bonding the soil particles together, waterproofing the particles, or the combination of the two. Such simplest stabilization process divided by two, which is compaction and drainage. As we all know that soil will be more strong if it is dry and will be more weak if it is wet. And soil stabilizations can be accomplished by several methods or broad categories, which are mechanical stabilization and chemical stabilizations. For a successful stabilizations, a laboratory test, for example, a loss in emissions, plastics tests, and everything followed by field tests need to be conducted to determine the engineering and environmental properties. So the result from all the tests before will enhance us the knowledge on choosing the binders and estimate the amount of binder that will be used in the future. So hence we can see that soil stabilization works need to be done to overcome the problems of construction in engineering. Problem statement. So, over the last year, we can see that the fast development and increase in population in Malaysia has resulted in the shortage of suitable land for development. So, this kind of conditions, especially in city, have become too dense and the price of the property have been rising dramatically. Also, due to the atmospheric deposition, severe irrigation, and others had caused the air and the clay soil in some areas, especially in the city, contaminated by the accumulations of the heavy metals. We know that heavy metals basically go into the atmosphere in the form of aerosol and deposit to the soil through major sedimentations and precipitations and by many other ways. These kind of issues have prompted humans to use industrial waste as alternative to some construction material. So if there is no action by anyone, this problem can be worse and can lead the environmental to damage nor damage the building. Component of stabilization. To improve geotechnical properties of soil, such as compressive strength, soil strength, permeability, and durability, we need to use stabilizing agents, or we call it as binder. So the components of stabilization is first soil, second stabilizing agent, and the last one is factor effective strength of stabilized soil. Stabilization method. Soil stabilization method is widely used to enhance the strength of soil and reduce the compressibility through bonding in the soil particles together. By this process, it makes the soil more stable and reduces its volume change and makes it proper for use. For this purpose, some admixture should be added to enhance their properties. Soil stabilization can be achieved by crushing the natural soil and mixing it with a chemical additive, then compacting the mixture. Under this process, soil stabilization depends mainly on the chemical reaction between the additive, which is lime or cement or fly ash or bitumen, and the soil itself to achieve the desired change. Many of the researchers have been used those previous admixtures in the soil stabilizations and gave good results in enhancement of the engineering properties of the soil, but the cost is quite expensive. So reuse of solid waste in the stabilizations of solid has rapidly increased in recent years. Solid waste used in soil stabilizations as standalone stabilizer as well as auxiliary additive to conventional and cement. A lot of solid waste have been probed by researchers for their effectiveness in soil improvement, and also because of solid waste is cheap and free, so use it more wisely.
Hi, my name is Muhammad Arif Akil. First is in situ stabilization. The method involves on-site soil improvement by applying stabilizing agent without removing the bulk soil. This technology offers benefit of improving soils for deep foundation, shallow foundation, and contaminated sites. Depending on the depth of the treatment, the in situ stabilization may be regarded as deep mixing method or mass stabilization. And for the deep mixing method involves the stabilization of soils at large depth. It is an in-situ ground modification technology in which a wet or dry binder is injected into the ground and blended with in-situ soft soils. The aim is to produce the stabilized soil mass which may interact with natural soils and not to produce too stiffly stabilized soil mass like rigid pile which may independently carry out the design load. The design load should be distributed and carried out partly by natural soil and partly by stabilized soil mass. Next is quality control and quality assurance. In deep mixing methods, automatic quality control and quality assurance must be implemented. A variety of installed monitoring instruments in the mixing machine and binder feeder may help to control column positions, mixing proportional, binder quantity, penetration, and retrieval speed. The typical application of deep mixing methods group into two main, non-structural purposes and structural purposes. Deep mixing application categorized into 6 main applications: hydraulic barrier system, retaining wall system, foundation support system, excavation support system, liquefaction or seismic mitigation system, and environmental remediation system. For mass stabilization is a shallow to deep stabilization method in which the entire volume of soft soil can be stabilized to a prescribed depth. The technique is relatively new and is highly suited for stabilization of high moisture content such as clay, silt, the organic soils and contaminated sediments. It is also offers a cost-effective solution to ground improvement in situ 28 remediation, especially with a huge number of contaminants and high water content. The method provides us as an alternative to traditional method of soil improvements such as removal and replaces technique.
Hi, my name is Alasha binti Azmi. I will continue with discussion. Soil is one of the most important material used in variety of construction projects including earthwork and earth depth. The clay soil will high strength in dry condition but exhibit low strength in wet condition. Expensive soil, mostly clay, often requires treatment by stabilization. They are characterized by the phenomenon of swelling when wet. This makes them highly problematic as foundation soils. Clay soil is widely used in most of the construction projects as it has good plastic properties, so that increased moisture results in their decreased shear strength, compressive strength, and volume changes. The soil behavior can be a challenge to the designer built in infrastructure plants to on clay deposits. One of the methods for soil improvement is that the problematic soil is replaced by suitable soil. The high cost involved in the method has led researchers to identify alternative methods, and soil stabilization with different additives is one of those methods. Based on the short review of this study, treatment of the soil with cement reduces the volume changes in soils, but this type of treatment becomes unsuitable for soil with high plasticity index. This research paper also addressed some fundamental and success soil improvement that used in civil engineering field. Adding cement agents such as lime, cement and industrial byproducts like fly ash and slag with soil results in improved geotechnical properties. In this case, stabilization of problematic soil including contaminated soil, peat, silt, and the like through adding materials such as cement, lime, bitumen, etc. is one of effective methods for improving the geotechnical properties of soil, which has been applied for many years. There are a great number of techniques for stabilizing that can be used for various purposes by enhancing some aspect of soil behavior and improving the characteristics of soil. Most available remediation technologies for treatment of contaminated soils are very expensive and result in residues requiring further treatment. Also, this research paper overview of the data published on stabilizing the various types of contaminated soil, such as heavy metal and toxic metal like arsenic, chromium, copper, plumber, and zinc, using different additives like ordinary Portland cement, rice husk, ash, lime, synthesized zeolite, etc. To achieve the best stabilized or immobilized soil, different additives including inorganic binders such as clay, like bentonite and kaolinite, cement, fly ash, blast furnace sludge, calcium carbonate, iron or manganese oxide, charcoal, zeolite, and organic stabilizers such as bitumen, compost, and minerals, or a combination of organic and inorganic amendment may be used. And the last one is conclusion and recommendation. This review paper represents the finding of 30 research studies on the stabilization or consolidation method of contaminated soil. One of the objectives of the research is to compare the result obtained by previous study on the stabilization or consolidation method of contaminated soil. The results from previous research studies have been chosen and compared to get the best method on the contaminated soil. Based on the previous study, we found that there are many methods can be applied on contaminated soil. The common method used are protein compaction test, attribute limit, and confined compressive strength, California bearing ratio, and more. previous study has exposed us to the relevance of actual waste is disposed as waste in engineering and for stabilization purposes. We can utilize the actual waste as a useful soil stabilizing material. By using the actual powder as a soil stabilization, we can minimize the waste disposal problem. From various laboratory tests has shown us that the utilization of eggshell as replacement of cement or as a soil stabilizing material will improve the soil properties, thereby making the soil suitable for construction properties. Eggshell improve the quality of soil by significantly reducing the pesticide indices. The CBR value of soil sample increased considerably with the addition of eggshell powder. Eggshell powder has high potential to improve the engineering properties of soil and mark more influence on strength characteristics of soil. From the result of this research study for the 30 journals, we can conclude that this research achieved the main objective of method used in previous study on the stabilization or consolidation of contaminated soil. From the previous research study, it is better to keep or recycle waste eggshell since it can be used for construction materials and reduce the disposal problem. Other than that, relevant authorities should collaborate in the management and disposal of the solid waste to save the environmental from pollution. This recommendation should be used to improve the further research study.